Hi guys, how we doing? I'm going to be going a little fast. Hopefully you know we're reaching the end. We're on the last part of the chapter, 11, 5, 6, and 7. We're doing bits and pieces from each of these, so hopefully you follow along. And this is more like some common sense stuff as well as some names of some things that you need to know. Okay, first one is called the line of symmetry. Okay, and the line of symmetry is a line that is symmetric. Now, you should know what symmetric means. Hopefully you do. It means that if I were to have a parabola, the line of symmetry is what cuts the parabola right down the middle. And of course, it would go right through this point, which would be called the, what do we call that point? Right, it's called the maximum. Okay. But specifically, it's called a maximum. Generically, it's known as a vertex. It's called the vertex because it's where it changes directions. We go from increasing to decreasing. The vertex happens on any parabola. So if I go like this, my vertex would be here. But now, the name of that vertex is called an absolute minimum. All right, so understanding the difference between a minimum and a maximum, what is the vertex, and that the vertex is located on your axis of symmetry, okay, or line of symmetry. That line is equidistant, or cutting this into two equal pieces. Now, why is this important? This is important because every point along here is the same distance from that line. Okay, so if this is 5 units away, this is 5 units away. If this is 25 units away, then over here would also be 25 units away. Okay? Now we're talking about the distance. I haven't used any concrete numbers yet. I'm just talking in theory that everything is the same distance all the way down this parabola. Okay? So your y's have two x's, except for at the vertex. All right, now just a quick review. You learned about factored form. Factored form is when you had a problem that looked like this. Okay, and when you had it in factored form, these were how, or this was how you found your zeros. Your zeros are your x-intercepts. We found our zeros by taking x minus 30 and putting it equal to 0, taking x plus 2 and put it equal to 0. We're finding the zeros, which are the x-intercepts. The zeros here would be x equals 30 and x equals negative 2. Now, these are not the points, they're just part of the points. Well, that means everywhere the x-intercept is where the y is what coordinate? 0. Okay? So in this case, this x-intercept would be here. All right, so understanding how we find the zeros and then being able to work backwards. So let's pretend I gave you the x-intercepts, and I said it was negative 7, 0, and negative 1, 0. Okay, so here are my x-intercepts. If I wanted you to write that in factored form, hopefully you understood that these turned opposite. Started as negative 30, came positive 30. So if I worked backwards, I would start at negative 7, and it would become x plus 7 and x plus 1. Why? Because if I wrote this backwards, x equals negative 1, and then had to move it over, it becomes x plus 1 equals 0. And this is our zeros. A 0 here gives me a negative 1 there. Okay, working backwards. So you should be able to work from zeros to standard form and standard form to zeros. Relatively no-brainer. And you did that on the software. Okay? And you also did that on the homework for 11.4. Okay, you had to do that forwards and backwards. What are the x-intercepts? How do I write it in standard form? Or not standard form, factored form. This is called factored form. Okay, it's when you factor the actual problem. All right? So, what are we doing next? Well, now we're going to try and find this axis of symmetry. And the axis of symmetry is going to be in between these 2 points. Well, Mr. Frazier, how do I find what's in between? Well, what's in between 0 and 8? 4, correct. What's in between 2 and 3? 2.5. Well, how do you get that? Well, between 2 and 3, if you add 2 and 3, you get 5. You divide it by 2, you get 2.5. If you add 0 and 8, you get 8 divided by 2, you get 4. So you can find this axis of symmetry by adding your zeros or adding your x-intercepts. So if I add 30 and negative 2, I get 28 divided by 2 is 14. So my axis of symmetry would be at 14. So let's just do a quick generic graph. I'll do this, just quick. And let's pretend I go ahead and mark these off. It'd be 5, 10, 15, 20, 25, 30. So here we go. There's one of my x-intercepts. Then I go this way. This would be 5, so negative 2 would be somewhere around here. Okay? And I know that in between that is 14. So 5, 10, 15, and I put it right there. This is where my parabola changes directions. Meaning if I draw it going this way, it would turn right there and go up. Or if I drew it the other way, it would go this way and turn and come down. All right? So finding the axis of symmetry, I can take the zeros, add them together, and divide by 2. So let's look at this problem. Here were my zeros. Right? These were my zeros. My x-intercepts. So if I add negative 7 plus negative 1, what do you get? You add them together. What do you get? Hopefully you're using a calculator because I'm not going to do it for you. And divide it by 2. It would be what? Negative 4. Correct. Hopefully you got the answer negative 4. Which means when I go ahead and graph this, negative 4 is my axis of symmetry. So this time I'm counting by ones. 1, 2, 3, 4. Here's negative 4. Which means this is my axis of symmetry. Negative 1 is one of my points, and 5, 6, 7. Negative 7 is another one. Notice, they are the same distance from the axis of symmetry. Okay? So, understanding, adding the adding the x-intercepts and dividing by 2, I can find my axis of symmetry. Okay, and that works going all the way up and down the parabola. Whatever my two, as long as they're at the same y, I can subtract I can add my x's and divide by 2. So as long as their output is the same, I can add my inputs and divide by 2. So let's look at another one. Let's say I use negative 1, 4, and 5, 4. So if you look at this, my outputs are the same. My y values are the same, which means my x values are different. If I want to find the axis of symmetry, I add them together and divide by 2. So what's negative 1 plus 5 divided by 2? Correct. You should have gotten the answer of 2. That means on my graph, 1, 2, for these 2 points, 2 is the axis of symmetry. And I know that negative 1, 4 is up here. And 5, 4 is right here. And that this parabola would be going like that. Notice it changes directions at the axis of symmetry, or the line of symmetry. Okay, they're referred to the same thing, so you got to be careful. All right, now the catchy part. Here's the catchy part. If I want to know what the vertex is, I then have to take this x value and plug it in to the equation, to the problem, just like you did in the software. So if I wanted to know what the vertex is, I have to plug it back in. So here's 14, right? That's my line of symmetry. That's where the x value of 14, right? We did this one for the very first problem. If I want to know what the vertex is, meaning I want the point where that turns around, I take this 14, because it's an x value, and plug it into the original problem for x. So if I put 14 in here, 14 plus 2 is 16. 14 minus 30 is correct, negative 16. And I would multiply those two. So what is positive 16 and negative 16 multiplied together? Correct, it should be negative 256. That's what you get. So that means at the x value of 14, the y value would be negative 256, which means my parabola goes it goes really far down and then turns up. Okay, this is my vertex. So what am I going to do? I'm going to try another one. Let's look at one and see if we can do it from the beginning. If I were to tell you that this is the equation, and I turned around and told you what the axis of symmetry is. They told me that the axis of symmetry is x equals negative 1. If I want the vertex, I now take this number and plug it into the problem. So it would be negative 1 squared plus 2 times negative 1, just like the software, minus 15. So negative 1 squared, 1, plus negative 2, minus 15. 1 plus negative 2 is negative 1, minus 15 is negative 16. So my vertex is negative 1, negative 16. Finding the axis of symmetry, plugging it back in, and being able to tell me what the vertex is. Plug and chug. Get an answer for x, plug it back in. They're going to give you x, so you plug it back in. All right? Okay, we're good so far. Hopefully everybody's on the same page. Well, what happens if they give me the axis of symmetry of negative 1 and they give me another point? Let's say they say, okay, find another point of 5, 3. So they tell me 5, 3 is on this parabola. But the axis of symmetry is at negative 1. So here's negative 1. And that means you've got negative 1, 0, 1, 2, 3. So how far away is negative 1 from this x value? Because they're saying the axis of symmetry is negative 1. And this point is at 5, 3. So that means it's 1, 2, 3, 4, 5. 1, 2, 3. It's there. So if this is my axis of symmetry, if they want another point, where does that other point have to go? Hopefully you know it goes over here on the left, right? It has to go on the left. Why? Because this axis of symmetry, or line of symmetry, cuts my parabola. Well, if I've got one point over here, that means the other point's got to be over here. and it's still going to be at 3. It's just going to be the same distance. Well, how far away was 5 from negative 1? It was 6. 1, 2, 3, 4, 5, 6. So how many am I going to count this way? Correct. 1, 2, 3, 4, 5, 6. And then up 3. Because it's going to be the same distance on both sides. Now, I just have to write the coordinate. So I started at negative 1. This would be negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Notice, I added 6 more to negative 7. I added negative 6 more. Okay. So now it's negative 7, 3. Now, what value doesn't change? It's going to be the y value. Why? Because the y isn't changing. Remember, the y is giving me 2 outputs, or 2 inputs. I'm looking for 2 different x values for the one y. Remember, there's a lesser one and a greater one. And they're going to be the same distance from this axis of symmetry. So once you know the axis of symmetry, you can figure out how far away is that point. Okay, now go to the other side, and it's got to be the same distance away. So you can count if you want, or you can add. Either way is the same. All right? Okay, so now let's look at 11.6. Because 11.6 deals with understanding what a vertex is, okay? And once you understand what a vertex is, being able to write it in vertex form. So let's take this problem right here, and we know what the vertex is. We're now going to write it in what vertex form is called. Vertex form looks like this. Okay, so here's vertex form. Okay, and this should be in your notes as well from the software. Vertex form, you see that there's a blank here and a blank here. Now I'm going to tell you what these do. This is always subtraction, but this number is positive. If this number becomes negative, that would make this x plus something. So inside the parentheses, you have to read everything opposite of what it really is. Okay? Just like when we did from factored form and x-intercepts. Okay? We wrote the opposite equation. Same thing happens here. So if I look at this problem here, and I'm writing it in vertex form, what number goes in there? Hopefully you know it's going to be the number negative 1. But that would change this to x plus 1. Okay? Because the original form has a minus in it. And when I put in that negative number, that actually makes it a plus. Right? But the y term stays the same. Now this form is called vertex form because this is the coordinates of the vertex. This one's opposite of what you see. This is exactly what you see. So I'm going to do another one. If I were to say, what is the vertex? You'd be able to look at that vertex form and go, well, it says x plus 7, but I know that that means it's negative 7. And this is the one that is the y term for the vertex. This is 5. Now, why do I know that? Because if I put a 0 in for x, I find my y-intercept. What? That's where the y is. So that is vertex form. I take vertex form, I can find the vertex. It is simply understanding what happens. Okay? And we call these H and K. But notice, they're still in what kind of order? Alphabetical. A, B, C, D, F, G, H, I, J, K, just like X, and then Y. Okay, so understanding which one is which. Which is which. Now, how do I figure out if I'm in standard form or vertex form? They'll tell you. If they want you to write it in factored form, that's 2 sets of parentheses. If they want it in vertex form, that means that is your vertex that is there. Okay? Notice, anything that's in parentheses is always the opposite, whether it be in factored form or vertex form. They're the opposite. Remember? When it was in factored form, those were opposites as well. Those zeros, when we had to go backwards, we had to put them in. Everybody following along? Well, the same thing happens here. They're opposite of what you're normally going to see. Okay? So hopefully you understand how to get vertex form, how to find vertex, and what it means when you work forwards and backwards. Finding the axis of symmetry, being able to write what the vertex is. These are all things that shouldn't be too difficult. So I'm going to draw another one here. And you tell me what the vertex is. Who can tell me what the vertex is? That's vertex form. Tell me what the vertex is. So hopefully you already told me that the x term was 5. Why? Because it's the opposite. But what's the y going to be? Yes, the y is 0. There's nothing here, but you can always put plus 0. Good job. I am proud. All right, so now we have factored form and vertex form, understanding how each one looks and what they tell you. Okay? Now, here's the trick. These control, in vertex form, it controls how my parabola moves. So, we talked about parent functions. This is what a parabola looks like as a parent function. That means basic. Nothing happens to it. It's just f of x equals x squared. Okay? As I put other numbers in this problem, it causes this to move. It causes the parabola to shift. We call that translate. One of the numbers controls going up and down, and the other number controls going left and right. So that means this figure could move up and down, or it can move left and right. Now, using an educated guess, which one of these two numbers do you think controls going up or down? Hopefully you say this one, because it's the same as k, which is similar to the y-intercept, which is similar to moving up and down, right? This number is in with the x, and we know x controls going left and right. So the number in here controls left and right, and the number here controls up and down in vertex form only. Vertex form only. So this particular one would not go up or down because the k is 0, but it would move 5 to the right. Now some of you are looking at this going, okay, wait a minute, that says -5, Mr. Frazier. Isn't that 5 that way? That's -5. Yes, but what do we know about the numbers that are in the parentheses? They're always opposite, which means I'm actually at +5. I'm moving 5 this way. So that means my parabola would do this. Because it moved over 5 from where it was. So again, this number controls up and down, and this number controls left and right from where I started. Okay, so you should be able to tell me how it's being moved. If I do this, am I moving up and down or left and right? Hopefully you know I'm moving up and down. Why? Because this is not in parentheses. Am I moving up or down or left and right? Hopefully you know this time I'm moving to the left because it's in parentheses, and that means the 2 is supposed to be -2 this way. Okay, so these are translations, understanding how things shift in real life. Now, do you have to do anything with these? No. You have to be able to find the vertex and the axis of symmetry. That axis of symmetry is where you take the x-coordinates, right, the x-intercepts, add them together and divide by 2. That tells me where my axis of symmetry is. Once I find what my axis of symmetry is, I can plug it into the original problem, and it gives me the vertex. Gives me the x, the input, and the output. That vertex I can now write in vertex form. So all of this stuff has to do with being able to transform things, but it's not a whole lot of heavy-duty math. It's not something we haven't done before. If you want a vertex, you got to find the axis of symmetry, put it back in to find your y-coordinate for your maximum or minimum. Okay, so I'm going to repeat this slowly so that you can write it down, and you can pause the video. If I need a vertex, I must find the axis of symmetry. That's the adding and divide by 2. Once I find the axis of symmetry, I plug it into the original problem, and it gives me the y-coordinate for my vertex. Now I know whether or not my vertex is a maximum or minimum, because if this is both negative, that means on my graph it's down here, and my x-intercepts are up here. That means it's a positive. It is going upwards. If my vertex is above the x-axis, then I know my parabola is going down, because my vertex would be up here. My x-intercepts are always on the x-axis. All right, so knowing how to find the vertex. Writing it in vertex form is easy. It's a form. Notice, I have to put the opposite of what x is in the parentheses, squared, and then this is minus 16 because that just means down 16. So you can see how vertex form tells you where the vertex is. All right, now, do we have to talk about a few more things? Yes, we do, but we're not going to worry about that. Why? Because we've already done them. Knowing whether the parabola goes up, knowing whether the parabola goes down, okay? Understanding what zeros mean. So a lot of the work we're going to do the next couple of days is going to be review work and going over how to find a vertex and going over how to find the axis of symmetry and how to switch forms. Is it a ton of math? Not really. It's really nothing complex yet. We'll get to that later. All right, good luck, and I'll see you guys tomorrow in class.